Hello everyone, this is Madi Neser Mogaddasi. This is a project update for Open Food Fact. Outline of the project update is as follows. The pre-processing, which is about discussing data analysis as well as the data cleaning of the progress that I have so far. The data that I've gathered from the Kaggle website is about 900 megabyte data in the format of a tab-separated file or TSV. As a part of the data analysis, I gather about 160 features, which is more than 200,000 observations included in it. Out of these 160 features, which are included in the format of text and numeric data, only 80 features will be numeric and also providing helpful informations for the next step that I will discuss. I noticed that the data that I'm working on is very much sparse, meaning about the 40% of the data is included with NA or missing informations. As a challenge, I was not able to using the function omit to removing the old data because it will lead to finding an empty data sets. To overcome this challenge, I was able to removing the columns out of those 80 features that has more than 20% missing data. It was end up with about 16 column or 16 features that I will start working on different algorithms with them. The output that is showing in this slide showing that 16 features or 16 columns that after removing the missing data will be the output of the previous section of the algorithms. Having these 16 characteristic or 16 features, the next step I will use them to finding a group of foods that having the similar characteristics based on this particular columns that is being discussed here. For example, as we briefly look at it, most of these features are somehow related to the nutrition facts, such as the level of the vitamin, calcium, and iron for that particular food that is the data that we have representing that level of those particular nutrition facts. So the next step that I'm working on is to finding and clustering these foods and providing several topics or several groups that having the foods with similar nutrition fact. After cleaning the data, the next step is running a correlation matrix algorithm to finding that what feature or what particular vitamin, as an example, might have a corresponding correlated number or mass correlation relationship to the other vitamin or other features in the data set that I have. And also, as discussed initially, the goal of this project is to running a clustering algorithm, which I picked the k-mean and run it with a different number of cluster value or k to find out the different groups of foods that has the most closeness or most basically common characteristics in the respect of those 16 features that I discussed that have together. Obviously, I would like to running the measurement to know that how well the k-mean is performing, so with the different value of the k, and providing the result as a report. As another way to consider the performance of the clusterings, I'm also working on some visualization technique to basically showing these clusterings on the set of the correlation data as an output to not only find it out that how correlated this group are together, as well as that how well the clustering algorithm works. That was a quick update of my project. If you have any question, please contact my email address madi.moqaddasi@ttu.edu. Thank you.